Welcome back to our next video, rational exponents. So in our last two videos, we talked about the rules and everything that went into regular exponents, but now we're going to go on to the rational side, which means we're going to start throwing in some fractions, okay? So it says, while exponents are often integers, exponents can also include rational numbers such as fractions. In A and B, apply the product of powers property to find the product and then answer the questions that follow. So, in example A, we see 9 to the power of a half times 9 to the power of a half equals. Now, because those bases are the same, I can combine them, which is what they did in this step, and then it wants me to create the new exponent. Now, mathematically, I would hope that y'all would know that at this point we are multiplying, therefore when I multiply, keep the base, add the exponents, and I would surely hope that y'all would know that 1/2 plus 1/2 equals 1. Hopefully we can do that computation in our head. So the new exponent is 1. And now remembering back to our power of 1 rule, anything to the power of 1 is simply that base, so the number 9. But if you needed a visual representation, type it in your calculator just to give yourself that extra assurance. Okay, now it does say, based on example A, what is the value of 9 to the power of 1/2? So see, in this example here, they're throwing in that 1/2 exponent right there, making it going from a rational number, going from an integer to a rational number. So you might not be as good at that one in your head. So this is where I would definitely lean on my calculator. Type that base, hit your exponent key to make your fraction, alpha y equal 1. Type your 1/2, right arrow, and you get the output of 3. Well, interesting. I started with a 9, and a lot of us think, oh, we're just going to take half. Well, half of 9 is 4.5, not 3. So somehow I went from this situation to a 3. So I want you to be kind of thinking of how we can get from a 9 to a 3. And we can't divide and we can't multiply. So we got to think about how we got this to work. Let's see what happens in example B. Example B says 16 to the power of 1/2 times 16 to the power of 1/2 equals. Bases are the same. Keep the base being multiplied. Add the exponents. And just like in the example previous, 1/2 and 1/2 create 1. And anything to the power of 1 is just that base number. Okay? Now, let's see what happens here. Because it does say based on the example B, what is the value of 16 and 1/2? So 16 to the power of 1/2. Let's see what happens. Oh, it got me 4. 1 second. That bell is so rude. Okay, so somehow 9 to the power of 1/2 got me a 3. 16 to the power of 1/2 got me 4. There is a certain operation that would allow these two to turn into one another, or these two to turn into one another, and I'm about to address that now. Based on both A and B, we can conclude that by raising to the power of 1/2 is the same as taking its square root. This can be explained with the rational exponent property shown below. Use the property to rewrite each exponent in A through D in its radical form and then evaluate. So there are times that sometimes your question will just want you to identify what the radical form is. 3 to the power of 2 is 9. 9 to the power of 1/2 is 3. So you're able to go back and forth between these because of the inverse operation rule. 3 to the power of 2, the reciprocal of 2 is 1/2. So 9 to the power of 1 over 2 will be 3, and 3 to the power of 2 will go back to 9. So everything, this is why I fell in love with math to begin with. It just all ties back together somehow, some way. So that's what the purpose of the rest of this is just kind of for you to be able to identify what that means and how to go from one to the other. Now, what I will like to say is you will not ever hear me refer to this symbol I'm about to show you as just the square root symbol, because that would be a misrepresentation. It is called a radical, and it looks like this. The reason I do not call that a square root is because you're not always taking the square root of a number. There will be times that you take a cube root. There will be times that you take a 5/6 root. You just have to know when the symbol will appear. Now, in this example, they give you a to the power of x over y. How you know to put a radical symbol is you have a fraction as the exponent. So anytime you have a fraction as the exponent, it's a good idea to just go ahead and put your radical sign. Now, the base is a, therefore a will go on the inside. Okay? Now, the x and the y have very specific placement that they have to be in. X, the numerator, will be the exponent, which is why I called it x, kind of help you remember. X exponent, numerator is the exponent. And the y, the denominator, is actually the name of the radical. So as you can see, we put the x inside with the a and the y outside, naming the radical. I do want to come back up here real quick just to kind of give you a visual of what that looks like. I have a fraction, therefore I need my radical sign. My base is 9, so it will go on the inside. Now let's place the 1/2. 1 is attached to the 9, and 2 is the name of the radical, meaning square root. Perfect. Now double check that. I do not have to type in the 2 for the square root because the calculator already recognizes that. That is this symbol right here. So second, and then that button gives me my radical. Type the number 9. You are not required to put to the power of 1 because remember, mathematicians are lazy. Hit enter, and then would you look at there, you get a 3. And then the same rule applies here. I have a rational exponent. Gonna put that radical sign. 16 is the base. There we go. 1 is the exponent. Put it at the top next to the 16. And then the 2 is the name of the radical. Therefore, that is a square root. And type that in. Square root of 16 is 4. Now, I am going to give you an example of how to type in a different type of radical symbol if you're required to, but that is how you would do the square root in the calculator. Now, this next part, it says if x equals 1, the expression is equivalent to. Now, this is just wanting you to rewrite this expression right here. So I'm going to rewrite what we already had. Let me use blue. We had this radical sign, a to the power of x equals y. And it's just wanting you to rewrite that, but now as x as 1. So when I do so, I still need to do my radical. Y didn't change, a didn't change. The only thing that changed was they put a 1 as x. And that is just the paper's way of wanting to make sure that you understand that the exponent does go on the inside. Okay? Now let's do some examples here. Example A says 100 to the power of 1/2. Now, you see a fraction as an exponent. I want you to go ahead and associate that in your mind as a radical sign. At least you can give yourself a starting point. Now your base goes on the inside. Perfect. Now the placement of the fraction. I have a 1 over 2. I know the numerator is in the x spot, meaning exponent, so 1. And then the denominator is the name of the radical, therefore a 2. So I know that that is a square root, square meaning 2, and then the root symbol radical. And I know, or should know, that the square root of 100 is 10. If you need to double check that, you can. But hopefully we know that the square root of 100 is 10. Moving on to B, notice now I still have a fraction, therefore I still have a radical. Here we go. The base now is 81. Write that in. My exponent is 1/4. 1 is in the x spot, so it goes with the 81. And now the radical name is 4. So this is no longer a square root, meaning that this button that we've been using is not going to work. It is a 4th root now. So to get those in your calculator, I want you to be familiar with this process. I'm going to clear out everything we have. You're going to hit the button that says Math. And you can see all of your math options here. We're actually going to look at this one, number 5, just like that, where now I can put the radical name here. So notice it's blinking a small square. We're going to type the number 4. And it gave me a little arrow signifying that I need to hit the right arrow to get to my next spot. And I want you to see it matches what I have on the paper. Now I put the 81. The exponent is still 1, so it's not necessary for me to put it. Right arrow out. And now I can properly take the 4th root of 81, and I get 3. So, like I said before, you can use your calculator to do all of these things. I could have typed this straight in and still got the number 3. But the point is for you to be able to write it in its radical expression, okay? So now I want you to pause the video and I want you to attempt C and D without me. Hopefully that wasn't too difficult for you. So you should have gotten 6 on C and then 4 on D. On C, I almost said 6, I'm sorry. On C, notice I have the 1 on the inside, the 3 on the outside. The name of the radical is the 3rd root. Now, that means that the 3rd root of 216 equals 6, and I was able to type that in your calculator. Some of you probably noticed that if you hit math, there is a 3rd root option. You don't have to hit the number 5, but if you're comfortable just using the same button every single time, you can always hit the number 5. And then on D, now D was a little bit tricky one because you notice the exponent on the inside went from being a 1 to now it is a 2, meaning that when you type that in, you can't be lazy on this one because now you have a number, meaning you had to put 8 to the power of 2 and you got 4. For those of you that need to see me do that, I will go ahead and do so. 8, now power button, 2, get out of the radical, and now you have something that will give you the output of 4. Perfect. Now, at the bottom, it says apply the rational exponent property to simplify each expression. I cannot express you enough. All we are doing is combining like terms and rewriting. There's really no solving. You are going to end with very crazy answers sometimes. That is okay. I do not want that to scare you in any way. So, with that being said, we have b to the power of 1/4. Nothing more, nothing less. All I know is I see a fraction as an exponent, therefore I can write my radical sign. Do my radical. My base is b, okay? And then I have the 1/4. Well, I know 1 is the exponent and 4 is the name of the radical. Okay, there's nothing else you can do here. The only thing that I can tell you to do now is to rewrite this properly. Oops, sorry, all the lights just went out. The only thing I can tell you to do is rewrite it properly. Your radical sign, b is your base, and 4 as your property name. You do not need to bring the power of 1 down because, again, it is not a necessary thing. Mathematicians are lazy. 1 second while I turn the light back on. Sorry about that. All right, moving on to number 2. Now, number 2 says 6y to the power of 1/2 times y to the power of 1/2. This can get tricky because of the way it's written. The first y has a coefficient of 6. The second y has a coefficient of 1. I would highly recommend separating all of these out because we are in the simplifying process. We do have a 6 that's a coefficient. We know that the rules of coefficient means multiply. So I can rewrite this as 6 times y to the 1/2 and still times y to the 1/2. The reason that makes your life a little bit easier is now you're not associating this 6 with these two bases. I am just simply trying to combine bases if I can. 6 is a number, y's are variables. I can't do anything with the 6, so I'm going to bring the 6 down. Now, in other examples, we'll be able to do something with the numbers, but in this case, I can't do anything with the numbers because, again, these are all just ones. So 6 times 1 is just 6. If you need to put that 1 there so that way you can see what I'm referring to, you can. And again, it's not a necessary step. So 6 times 1, boom, I have a 6. Notice I kept everything with its own thing. I kept numbers with numbers, and I kept variables with variables. But now I can address these y's. The y has a 1/2, and the other y also has a 1/2. That is being multiplied. When I multiply, I keep the base. Now I'm going to put the times y, and I add the exponents. So just like above, 1/2 times 1/2 is just the value of 1. So, although that is an acceptable answer, it can be rewritten as simply 6y. And that is also an acceptable answer. So please do not trick yourself whenever it comes to this separating out. Please separate them out if you can. Now, example number 3, I cannot separate them out. You want to know why? It's inside of a group. That is a grouping sign, meaning I can't separate that group. Here, I had no grouping symbol. I can separate that out all I want to. Here, I cannot because of this boundary that it gave me. It gave me barriers that I cannot mess with. So now I have to think about my rules. I have 81x to the power of 6 to the power of 1/2. So when I think back to my rules, this is a power of a product because I have 81 being multiplied by x to the power of 6, and then both of those things are now raised to the 1/2. So now I have to think, okay, great. What was the power of a product rule? When I have a power to a product, distribute the power to each term. I've got to distribute my powers. So, with that being said, I would rewrite this so that way I could see every term's exponent. So we have 81 to the power of 1, x to the power of 6, and 1/2 as the final exponent on the outside. So with that, I now can distribute, because remember when you distribute, you are distributing to the powers only. Only to the powers are you distributing. So I now have 81. 1 times 1/2 is going to be 1/2. And then x to the power of 6, but then 6 times 1/2 is going to be 3. So now I have a situation where I have a number raised to a 1/2 and then x raised to a 3. Well, I can't do anything to this x to the power of 3. There's nothing I can do to it but this 81 to the power of 1/2. If you can remember, that is a rational number exponent. It is a fraction. Therefore, I'm going to be computing some sort of radical. We've done enough with 1/2 that I would hope that you would know the radical of 1/2 means square root, just like it did in our examples above. So the square root of 81 is 9. Now, in case that is too much information for you, you are allowed to type that in and you would get the same answer. Please do not feel like there's only one way to do things. There are multiple ways, and I would rather you feel 100% confident. So always double check yourself if you can, but instead of 81 to the power of 1/2, I can replace that with the number 9 and be on the same track. Okay, I want y'all to pause the video and try example 4. Hopefully you got to this point where you distributed, you have a power to a power. So when I have a power to a power, keep the base and multiply the exponent, which is what we did. We did 1/3 times the -9 and got -3. So when I rewrote that, I have x to the power of -3. But then there's another rule. The negative exponent rule is I cannot leave an exponent as negative. So when I have a negative exponent, rewrite as the reciprocal. So if you remember, this is actually over the power of 1. So whenever I want to rewrite it, but it be positive, I simply put the 1 in the top, put the x in the bottom with a positive exponent. So see how all of these rules kind of tie back into each other. You can have multiple things going on in one problem. So now, moving on to number 5, clear this out. X to the power of 3 to the power of 4 times 4x to the power of 10 to the power of 1/2. Whoa, there's a lot going on in this one. We are going to take it one step at a time. The first group is x to the power of 3 to the power of 4. Well, that one's actually pretty simple. We have a power and a power. When I have a power to a power, keep the base, multiply the exponents. 3 times 4 is 12. Okay, perfect. That took care of the first one. So now I have another one. I have 4x to the power of 10 to the power of 1/2. You cannot forget that this is a product, that is a power. So whenever I have a power of a product, keep the base, distribute the exponent. When you distribute the exponent, you have to remember you are distributing to everything's exponent only. So when I rewrite this, because I'm multiplying here, I'm going to put a dot. I now have 4, I'm going to show my little distribution marks here, 4 to the power of 1/2 times, because I'm still multiplying, now I'm just showing that I'm multiplying, x to the power 10 times 1/2 is 5. Okay, perfect. So this super complicated looking problem, you just condensed it down, but you didn't condense it down all the way. Now I have 2 x's and I have the coefficient. Let's take care of the coefficient first. 4 to the power of 1/2. I can do that 2 ways. Recognize that that's a rational number, so I'm going to be dealing with some sort of radical. 1/2. Oh, I know what 1/2 is. That is the square root. Well, the square root of 4 is 2. But just in case I forget, I can always type that in. Oh goodness, if I could type it in correctly. There we go. 1/2. And you still get a 2. Perfect. So I know my new coefficient is going to be 2. But then I have x to the power of 12 times x to the power of 5. When I multiply, keep the base, add the exponents. 12 plus 5 is 17. So I've now rewritten this entire expression here as 2 times x to the power of 17. Now I want you to notice everything is separated. That power of 17 applies only to the x, and the 2 has an exponent of 1. Now, hopefully that cleared up any questions you might have had about fraction as exponents. But again, you can always go back to your calculator here and rewrite if you need to. This is more so that way if you get like a word problem that says which one is written in radical form correctly, you would be able to do that. The most important part is when you see a fraction, remember that the numerator is the exponent and the denominator is the name of the root. Okay, I'll see you in the next one. Bye.